Welcome everybody to another one of James's videos. Today we are going to be dealing with trigonometry grade 11 equations, and it's the type 3 question where I'm going to expose you guys to the co-ratio method of solving for a trigonometric equation. Now, how do we know when to use this method to solve for this equation? Well, the concept is if we have sine and cos on either side of the equal sign and the angles are different. So let me write that out quickly. Let's rather write it here. When we have sine and cos on either side of equals and the angles are different. Okay, so remember we did in our previous video, we dealt with where our angle was actually the same, which allowed us then to create the tan because we could divide both sides by cos. But here we unfortunately can't do that. So what we're going to do is we're now going to say to ourselves, cool, so we're going to want to change the right-hand side into a cos. Now, the reason for that is because we need the same trig function on both sides in order to extract our reference angle. So what we're going to do is how do we make a sine a cos, guys? So what we do is we use our co-ratios. So cos of theta minus 20 will equal cos of 90 minus theta plus 40. Okay, so that is me changing the sine into a cos using my co-ratio method, hence the name of this type of question. Now, once that's done, I've got cos of theta minus 20 degrees equals cos of, if we times this out, it's going to be 90 minus theta minus 40. Therefore, cos of theta minus 20 equals cos of 50 minus theta. And now we're at a point where we can extract our reference angle. Now, guys, the reference angle for these types of questions, I always say, commit to a side. This angle we are going to solve for in our general solution, which makes the right-hand side's trig function's angle your reference angle. So your reference angle here will be 50 minus theta, okay? We would still use our sine of the right-hand side's cos to determine which quadrants we're going to be doing our general solution in. So what are we looking for? We're looking where cos of an angle is positive. So where's cos positive? Cos is positive in the first and the fourth. So we will still be working out the first and the fourth quadrant, okay? So the first quadrant is going to be the theta minus 20. That's the angle we're solving for, guys, the left-hand side cos's angle. And we're going to say equals, first quadrant is known as the theta quadrant, so we can just put our reference angle there, plus K360, K is an element of integers. And then the fourth quadrant is going to be theta minus 20, which is the angle we're working out, equals. Now, isn't the fourth quadrant known as the 360 minus theta quadrant? So we have to go 360 minus my reference angle. Remember, guys, the brackets. Brackets are important because we still need to times in that negative. Times K360, K is an element of integers. And now we can solve for this. So what we're going to do is we can bring all our thetas over. So that's going to give me 2 theta. Bring the minus 20 over, it becomes a positive. So it's going to be plus 20, which is 70, plus K360. K is an element of integers. This side, we need to do a little bit more simplification. So let's times that negative in, like what I mentioned before. Plus theta, plus K360. K is still an element of your integers. Okay, so then what we're going to do now, we can bring the thetas over. And what's going to happen here? If I bring the thetas over, guys, do you agree with me that the thetas are going to cancel? It's going to leave me with 0, and that's going to be 310, so 330, plus K360. K is an element of integers. So if the thetas cancel, guys, that means there's no solution on this side, okay? Because obviously, remember, in normal equations, when your your x's cancel out, or if your y's, your variables cancel out, and it's 0 is equaling a number, that doesn't make sense, right? Because 0 can never equal 330 plus k360. So no solution for the fourth quadrant, but we can continue to carry on in the first quadrant. What we first need to do here is divide everything by 2, so that gives you the 35 degrees, plus the k180. K is an element of integers, and that would be my general solution for this question. Okay, and that's where I would stop. Do you notice why I'm not subbing in the values of k? Because they didn't ask me to solve for specific solutions, because they didn't give me a domain. They just said solve for theta, which just allowed me to stop at my general solution. Remember, if they give you a domain or a restriction, you need to then sub values into k and then get your specific solutions until it's fallen out of the domain given. Okay, so that is the co-ratio method of solving a trigonometric equation. Remember, when we have cos and sine on both sides of the equals with different angles, okay, hence the word different, we then leave the left-hand side, whatever trig function it is, and we try and we make the right-hand side the same function. So how did we make the sine a cos? We use co-ratios. Sine can change into cos by going cos of 90 minus the angle of your sine. And then once we get to this point, we just take the right-hand side's trig function's angle as our reference angle. The left-hand side trig function's angle we then solve for in our general solution step. Okay, hope you enjoyed that video, guys. We're going to be doing a few more examples on this, some to do with factorizing later. So if you like the video, please click the subscribe button below. And all of this can be found in our James book, which is for sale. So please, if you want to make contact with us and you want a copy, please drop us a comment or get in contact with us via the website, and we'll be happy to set you up with a James book. Great, guys. Have a good day. Bye.